Okay, this is a topic assessment I want you to do as a handing in homework. So first one, just differentiate. Part 2, if you write that as 3 over root x plus 2x over root x, that is 3x to the minus a half. That is x to the 1 over x to the half, which is x to the half overall. And then differentiate it. Part 3, multiply out your brackets, tidy it up, then split it up. X squared over x4 is x to the minus 2. X over x4 is x to the minus 3. And that's minus 2 over x4 is minus 2x minus 4. So differentiate that and then tidy it up. Part number 2. So you have got, just watch your variables here. X equals. So times that out. Then when you differentiate, it's dx over du. And just differentiate it once and then differentiate it twice. Question 3. Curve has got this equation and you want the tangent at this point. So there's your tangent equation. Put your point in. To work out m, go over to the side. So differentiate, put your x value in. That gets your m. To give you your equation of the tangent. Now, part 2 of this. Find the coordinates of the point Q at which the tangent is parallel to the tangent at P. So parallel means the same gradient. Your gradient up here was 4. So you want the gradient to equal 4. dy by dx equals 4. You already have dy by dx. Just put equal to 4. It's quadratic. Put everything on one side. Solve it. That gets you your x points. This is your point P. So you're working with this point. It's a different point. Work out your y coordinate. Number 4. Find the equation of the normal. So there's your normal equation. Now I started off by writing this out a bit better. So x minus 2x minus to the power of x minus 2. So find the equation of the normal when x is 1. So when x is 1, sub it in to get your y point. Okay, so your point is 1 minus 1. So I'm subbing that in down here. To work out your m, differentiate and sub in your x value. To give you 5. And that's just me tidying it up. Part 2. Show that the normal does not meet the curve again. Here is your normal. Put it equal to your curve. Times everything by 5 to get rid of these fractions. Then times by x squared to get rid of this fraction. And then try to solve it. Okay. You know it meets at x equals 1. So x minus 1 is a factor. So you just divide through. So x minus 1 is that 1 equals 0. So x equals 0. Put this one equals 0. You get a negative square root. So it's impossible. So it only has the one root. Question 5. So you've got this curve. Find where it crosses the x-axis. It crosses the x-axis when y is 0. So put 0 in here and solve it out. Find dy by dx. So differentiate. Then find the stationary points. So put it equal to 0. Get your x. Don't forget to work out your y coordinates. And then next bit is find the second derivative. Put each of your points into it and see if it's max min. And this is pulling all together. Don't forget to put in your axes intersection there. Okay, so you put y equals 0 to find where it crosses the x-axis at. And that's your max and min points. Number 6. Okay, find the stationary points on this. So I would write that as y equals x minus 1 plus x minus 2 minus x to the minus 3. Differentiate it. Write it a little bit neater, just pop those x's back in the bottom row. Put it equal to 0, like so. Multiply everything by x4 to get rid of this. Gives you that equation. Change all signs to make it a bit easier. Factorise it or use the formula. You've got your 2x values. Work out your y's. Need to have your second derivative. So from this line up here, differentiate again. Tidy it up. Put in your 2x points. See what happens to second derivative. Min and max. Number 7. Two numbers are such that this. So you can rearrange to get y equals. Find the maximum value of the product. So I said let p for product equals xy. So x times your y. Maximum is when dp by dx equals 0. So put that equal to 0. Sorry, I have to differentiate that first. Put it equal to 0. Forget your x. Do your second derivative to show its max. And the question wants the product. So just put your x back in to see what the product is. Question 8 is a cuboid. So I drew it out. It's got a square base, xx, and height y. Show it the surface area. The surface area, the base plus the height, plus the front and the back, plus the side and the other side. Tidies up to give you this. You're told that equals 24. So I could write that as y equals. Divide everything by 2 first of all. You can see me manipulating there to get y equals. The volume is base times height, so x squared times y. Use your y in there. Timesing it out, you've got your volume. Maximum is when the volume, or dv by dx equals 0, so put it equal to 0. Times it out to get your x's. You can't have a negative x for a length, so choose x equals 2. Do your second derivative, just check everything's working out. Then work out your maximum volume by putting your x into your volume equation. And the last bit of that, use differentiation from first principles. See it there? You do not need